Hello YouTube. I thought I might just make a quick video of fixing a Sonos soundbar that I'm currently doing for a friend. Like all good electronics projects, it's being done on the kitchen table because it's quite large, and my electronics bench is pretty messy at the moment. So taking apart the soundbar, it all starts with taking off the side pieces. There's a side piece on the end bar that looks like this, with the volume controls, and they're actually covered by a couple of bezels. So the start to taking the soundbar apart is by actually peeling off these bezels. They've got double-sided tape, and there's some screws. And once you take the screws out, you can take the side panels off. One of them, this one, has a volume control, and this one is just blank. The volume control buttons are on a small PCB. Once you've got those off, you can then unclip this sort of covering. That was quite simple to do. There's actually a connector which must have some front panel status indicators. I have to say I haven't seen the soundbar working because the problem with this soundbar is that it wouldn't power on at all, so I guess the power supply is dead. So what I've started to do is strip it down to get the power supply out. So yeah, after taking the cover off, I could then take the aluminium bar off. That was quite tricky to do. It is a very snug fit. There's a lot of screws in it as well, so that took a little while. Again, there's a few connectors. There's some LEDs on the top, which are these two connectors, and there's also infrared. This is clearly a infrared sensor on the front. So once I've got these two pieces off, I can then actually remove the speaker housing itself, which is this assembly here. You can see that there's well, 6 sort of larger drivers and 3 smaller drivers. So it's really packed with speakers. I'll give them that. It's a very thick molding, glass reinforced plastic of some kind, and it has a lot of the cabling on the outside, which has all the connectors to connect to these panels and things. There's also the antennas located outside. If we turn this over, you can see all the drivers here. I've actually disconnected, there's a connector on each driver, which I've disconnected. There's some wiring in here. All the wiring is wrapped in this foam stuff to stop vibrations, I guess. And this whole unit screws onto the base here, and it's got gasket material. So this is a sealed speaker enclosure principle, and all of the cables pass through using grommets and things. So there's quite a lot of engineering that's gone into that piece. So the base, here's the base panel. This has a lot of the wiring loom for the speakers fitted. Incidentally, if you're taking one of these apart, some of these tweeters have it looks like a spade connector, but they're a latched spade connector. So if you're removing one of these, remember to release the latches before you can take the plug off. And in fact, I've removed the PCB for the power supply, which was located somewhere here. And to take that off, you have to unpeel the label on the back because the screws are underneath the label. So here in this base assembly, we have a logic board with presumably the processor and things. There's this larger aluminium mounting that comes out and connects to the aluminium housing on the outside as heat sinking. And here's the amplifier section. So this is a digital amplifier. Well, there you go. That's all the pieces to get the power supply out. I'm mostly interested in the power supply. As this unit doesn't power up, there's obviously an issue with the power supply. Okay, so now I've got the power supply board removed from the soundbar. Let's have a look at it a bit more. I'll just zoom out here, and you can see this is the board entirely. Internally in the soundbar, these connectors go off to the logic and amplifier boards, and on the external of the soundbar, the power supply has all of the external connections, which is the mains, optical, and 2 Ethernet ports. One of the things that we can see is that there's this much larger connector, and that's clearly a power connector for the logic and amplifier board. These smaller connectors just connect to the optical and the Ethernet connector. One of the things that you can see about this is that if I turn it over, you can see that actually all this tracking is quite separate from the power supply tracks. Okay, so I've done a little bit of work to this board already, and I've just soldered in a fuse here. There was a small PCB mount, non-resettable fuse, and due to the nature of the failure, that fuse was open. So the first thing I did was I removed the fuse. I've just soldered in this lower value one temporarily whilst I debug what's wrong on this board. You can see this is the mains connector. So mains enters in onto the board, and one of the traces go through the fuse. So that's the entry of the mains. Now if we have a look at the rest of the board, I've removed some of the components. I have photos of the board before I actually removed any components. I'll post those up so you can see the board in its entirety. But what's obvious about this board is that we have a lot of the mains filtering input here, and then we've got a rectifier. This is clearly the primary stage of the switching power supply. And on this side we have this is a diode pack underneath this small heatsink, and there is some capacitors, and then some very large tracks that come out and along the bottom of this board through this inductor here, round, and to this output connector. So clearly this is the primary side of the board, and then this is the secondary mains input here, and the low voltage output of the power supply on this connector. On this connector you can actually see this is a large track, and it connects to the 4 center pins. The 4 outer pins actually go and connect on the track on the other side of this board. What's also convenient for repair about this board is that there doesn't seem to be any logic connections between the power supply controller and the main processor on the logic board. Sometimes this is there's control wires so that the logic board could shut down parts of the power supply. But on this device, on the soundbar, it seems that actually when you plug in the mains, this power supply just switches on and outputs its low voltage, and it's on all the time. So that's going to be make it a lot easier to debug, since it should operate without any of the logic boards connected. Okay, so I said that I've removed a couple of the components. Let's have a look at them here. I'm going to turn the board around actually, and you can see there's actually quite a lot of glue put onto the PCB. That's generally to stop to stop components falling off or being come off during transport or whatever. Makes it a little bit more rugged. Unfortunately, it does make repair a bit tricky. So I've actually you can see there's some capacitors here which I've removed. So there's one. And there's actually only two of them fitted. And the thing to do here is you actually use like a scalpel blade to gently cut the glue between the capacitor and the PCB, and then desolder the capacitors. So you can see there's the mains comes in, it goes through capacitor chokes, and then through another capacitor. This is commonly called a CLC filter. And then once we've gone through that filtering, it goes into the rectification stage. This is a full bridge rectifier, and these capacitors on the output of the rectifier are designed to smooth the DC output. You have to remember this is all at mains voltage and it's not isolated. So one of the things with debugging these boards you need to be very careful of. It's a lot better to power up one of these boards on a current limited supply rather than using mains. So we've removed these capacitors, and actually it makes getting debug access, getting access to probe the primary side a lot easier. Now actually I've also removed the main switching FET as well from here. I'll probably make another short video on why I've done that. Anyway, there's a switching FET there, and the MOSFET switches the primary side of the transformer, and then on the secondary side the output's rectified through some high-speed diodes, Schottky diodes. Once the output is rectified, there's some more smoothing capacitors. So one feature of switch mode power supplies is there's often feedback from the isolated secondary side back to the primary side, and this is done via a opto isolator which is fitted down here. You can quite often see that from the primary side there's a nice clear isolation between the primary and the secondary side. There's even a slot in the board where the transformer bridges over.